Till now, we have covered the concept of how we can create the ECS service. Using the ECS service, we can run the multiple tasks. But for example, this is a task 1, this is a task 2, this is a task 3. Task 1 has its own IP address 1, task 2 has its own IP address 2, task 3 has its own IP address 3. Now, if you have exposed any API, then we have to select which. Now we will be confused like which IP we have to hit, because same API running on the 3 different tasks. So this is not a good idea. It is not a practical feasible idea. So better option is to wrap all the tasks into one load balancer. Load balancer means we are wrapping all the tasks into one organized way. Another task will be initialized and the IP will not be affected. The URL in which we have to hit will not be affected. That will help us in managing the API effectively as compared to the individual task. So let's do some practical and understand this topic. Before starting the lecture, I advise you to watch the previous 2 lectures uploaded in the base to the ECR plus how we can insert the ECS service. Then only you can correctly grab the information given in this lecture. For example, when you are running ECS without the load balancer, then this is the, you can say, IP in which you are hitting the URL. But for example, by any chance your task has been stopped or your target instance has been stopped, then your IP will be changed. This will create the problem. See, public IP can change, not good for scaling, because if you say run on 2 or 3 tasks, tasks have different public IP. So you will be confused which IP to hit. Obviously, that's not a practical feasible solution. Now manual traffic needed. Now we have to manually see like which public IP the latest. Not production friendly, security issue is there, then no automatic health including. These are few examples. You can see the few disadvantages of using the ECS service without the load balancer. Now we will move into a later part. While doing the practical, we will get to know these things. Now first one is the create the application load balancer, ALB. So ALB is the load balancer which will marks all the tasks into one organized way. There can be common HTTP, HTTPS, web application APIs. A listener defining which port our load balancer will work. Look, your API port, your code port, you can say, can be anything, 5000 for example. But your listener port can be different to the 5000. Not necessarily it should be 5000. It can be 80, anything 80. It depends on you. Now let's understand this part, how it will work. Now your Flask API running on the 5000, but your listener is listed on the 80 port. So what will happen? User will give the request of the 80 port, not the 5000 port. And that 80 port will inside the application load balancer, and in return application load balancer will forward this to the ECS task on the port 5000. So this is a very practical way. Usually we follow this route only. First we will start the listener. We will use the port on defining the listener, and then listener will initialize the load balancer. So there can be hundred of tasks running in different public APIs. Target group is the where this load balancer will send the traffic or send the request. This is simply group of the task. Right now it can be confusing for you, but when we will do the practical, then you will get the correct understanding. Is the health check, like whether our API running fine or not. This we have discussed in the last lecture also. Now different tasks have the different status. For example, task 1 is running healthy, task 2 is unhealthy, and then task 3 is healthy again. So user open the browser, then it hit the URL. Then that URL will not go to the task directly, as discussed in the earlier lectures, but it will go to the load balancer. Then that load balancer will hit the listener using the port specified in the listener. Then the listener will inside the target group, and that target group will written inside the ECS task. So these are 3 to 4 steps added extra here, and this will give you the more organized as compared to earlier. Let's follow the steps. Open the AWS. Now search for the target group. These are the target groups. Target groups are the feature of the EC2. Now create the target group. IP addresses. You have to select the address type. Protocol should be HTTP. Port we are using the 80. Sorry, port here it is 80, but we have to use the port in which our API or code is running. 5000. For the health, we have initialized the health URL. Now our group has been initialized. The second part, we will initialize the application load balancer. It is again the part of the EC2. Go to the load balancer. Okay, this is the wrong URL. There are two load balancer. One is the light cell feature. No, not this one. EC2 feature. Create a load balancer. So the application load balancer. Now this one is the internet facing. We have to specify the internet facing because internet facing should have the public IP address, and we want the application load balancer which have the public IP address because normal user can access this, not the only organization user. Internal is used when only organization user. For example, you are working for any company, Britannia, and your only employees should access the this portal. Then you can use the internal. Else, if you want to make it open, then you have to use the internet facing. Name it load balancer 2. Let's name it 2. So internet facing. Listener is we have to specify the listener also. In the listener, we have specified the port 80. The listener means the user will hit the 80 port. Although in the backend your tasks are running on any port, that doesn't matter. But the user will hit the port 80. Now select the target group from here. Select the target group which you have created just now. Now in the second step, now create this. Select the availability zone. Create the load balancer. Now our load balancer has been initialized. It is currently provisioning. It will take some time. Meanwhile, open the security group. Here we will have to add the port 80 also. Right now to port 5000. Open the security groups. Open this and add it in inbound groups. Right now it is 5000. Check it what we have done here. Apply the 80. Why we are applying the 80? Because 5000 is for the task. And right now we are not running we are not hitting the task directly. We are using the listener in between. Now our final step is to attach the load balancer to the ECS service. Go to the ECS service. This is the service which we are using right now. Create a new service here. Set a task definition, class API task. Just watch the previous lecture. We have created these task definition in the earlier lecture. These are things we have discussed earlier. In the load balancer, use load balancing. Use an assistant load balancer. Load balancer 2. Use an assistant listener. HTTP 80. Use an assistant target group. This is the target group 1. Now create. It will take some time to start. Now open this. This is the tasks which are running. Now check the logs. It's running fine now. Go to the load balancer. This is the load balancer. Copy this. Now use the HTTP. Copy the URL of the HTTP from the above. Now our API running fine. Hello from class API running on AWS ECS. So now we have completely run the class API. First we have created a class API inside our local system to the Docker. Then we have registered that image locally. Then we have changed the name of the image according to the AWS system. Then we have loaded the image to the repository. We have also created the repository here. We have applied the IAM user. We have created the IAM user where we have specified which role ECS and the ECR role we have given to it. Then we have defined the task. Using that task, we have created the service. Then in the first step, we have done normally these things. In the second step, we have applied the load balancer, created a target group, changed the security rules, okay, inbound rules, created a listener. We have used the apply, we have used the application load balancer. Why? Because to organize the service. Else, what will happen? You have multiple tasks. One task is running on different IP, another task is running on different IP. So it will be practically impossible to track all the IP addresses. So you have wrapped all the tasks into one load balancer and provided to the user. Now user will be provided with this only URL. Now in the backend there will be hundred of tasks. That doesn't matter. One task is failing, another task is restarting. That doesn't matter. Only user have to accept this. Okay. Thank you.